All right, I'm going to do my best. Sorry if that was loud. I'm going to do my best here, moving the mic as close to the smartboard as I can, so hopefully it's not too hard to hear. I'm going to go through all the problems, and I'm going to be using diagrams for them all, because I believe that that is the easiest way to illustrate these. Use this video however you see fit. If there's only a problem or two you need help on, so you can skip to that portion. Okay, problem 1. Harold made 14 cups of granola and divided it equally among 4 bags. How much granola went in each bag? So our diagram here has our 4 boxes. So we think about what in the problem also represents 4. It's the 4 bags that he divided the granola into. So I can show that. Just kind of that whole thing is going to be 14 cups of granola. Okay, I can represent this using a division problem. 14 divided by 4. Or I could set it up as 14 over 4, because that's a funky looking division problem. So then to find the answer to 14 divided by 4, I can take my improper fraction here, turn it to a mixed number. So groups of 4, can I take out a 14, 4, 8, 12. So that's 3 groups of 4. 3 groups of 4 we just said is 12. So when you take 12 away from 14, you've got 2/4 remaining. This reduces to 3 1/2. So I can put 3 1/2, and that would represent the number of cups in each batch, and I can verify to make sure my answer is correct by totaling those 4 3 1/2s up, and it should equal 14 total. So if I look at 3 1/2, 3 1/2, just 2 of them, that's 7, right? So if we have 2 groups of 7, that verifies that the 3 1/2 answer is correct. So 3 1/2 cups. And put a circle around it so we know what our final answer is. Select all the expressions that would result in an answer being greater than 1. You do not actually need to solve these. So we just did this week. And the big takeaway was if our dividend is larger than our divisor, the dividend being the first number of the problem, the divisor being the second, if our dividend is greater than our divisor, then we're going to have an answer that is greater than 1. Okay? So in A here, we have 3/4 divided by 5. Now, since we have a fraction divided by a whole number, that fraction, it just represents a number that's between 0 and 1, okay? And so because we start with a fraction and divide it by 5, which is obviously greater than 1, that answer would be less than 1, so we're not going to select A, okay? B is kind of almost the same, but it's flipped, right? So we start with a whole number, we divide by a fraction. And so because we start with that whole number, any whole number is going to be larger than a proper fraction, okay? That changes when they get improper, like in C. But in B, that 7/8 is still just a proper fraction, and so we know that answer is going to be greater than 1, because 3 is larger than 7/8. 10/3 divided by 11/3. They're both thirds, so really we can focus in on that numerator, okay? 10/3, think of 10 1/3 pieces divided by 11 1/3 pieces. Because they're both thirds, that 11/3 would be the greater number, and so that one would not result in an answer greater than 1, because 10/3 is the lower value. In D, 7/8 divided by 2/5. This one we have different denominators. I know 7/8 is really close to 1 because it's only 1/8 away from being 8/8. 2/5 we know is less than a half because 2/4 would be a half. So 2/5 is going to be less than a half. So we know D would be greater than 1 because 7/8 is greater than 2/5. 3 and 3/4 divided by 2 and 3/4. So their fraction parts are the same. The dividend has a 3, and the divisor has a whole number of a 2. So that one is going to be larger because that whole number 3 is larger than our whole number of 2. So B, D, and E. Select what will be true about the quotient in each equation based on the size of the dividend and the divisor. So this goes back to an activity we did, a card sort we did early in the unit where we were given like 20 different expressions that we had to sort into the columns of the quotient, which will mean answer. The quotient will be close to 0, the quotient will be close to 1, or the quotient would be much larger than 1. I'm just going to throw some example problems out for us to see what each of these might look like. So for one that a quotient would be close to 0, we would need to start with a very, very small number, like let's say 2, and divide that by a very large number, let's say 100. 2 divided by 100 is 2/100. That's a very small number. That is close to 0. In order for one of them to be much larger than 1, our dividend and divisor from the first example would have to almost be flipped. So a very large number, like 100, divided by 2, that's going to give us a quotient of 50, which is much larger than 1. For a quotient to be close to 1, your dividend and divisor are going to be about the same size. So 99 divided by 100 is 99/100ths, and that number is very close to 1. So in this first one, 45 divided by 1 7/10, that 45 is significantly greater than 1 7/10, and so that's going to compare kind of to like this middle example I gave you. So that quotient will be much larger than 1. 12 divided by 14, that's going to compare very similarly to that third example I gave where the dividend and divisor are very close to each other. So that's going to give us a quotient that is very close to 1. And then 36 divided by 1,464, that one is going to resemble that first example I gave. Even though 36 isn't like a small number, when you compare it to the 1,464 that it's being divided by, it is a small number when you compare it to that. So that one is going to give us a quotient that would be close to 0. All right, select all the statements that would show correct reasoning for finding 13 divided by 4/5. So before I even look at these answers over here, I'm just going to think, if I were to solve 13 divided by 4/5, okay, some strategies I might use. Keep, change, flip is one we can always use when we have division, and I can turn that into a fraction, right? So if I were to use that, I would have to go 13 over 1, keep, right, first fraction the same, change your operation sign, flip your second fraction to its reciprocal. If we do that, we end up multiplying 13 by 5, which I don't know what that is, but I'm just going to write that's what I would do first, 13 times 5. And then you multiply 1 times 4, you get 4 here, so then you would have to divide it by 4. So I see that that matches C. Right? Multiply 13 by 5 and then divide it by 4. Now, the question says to select all the statements. So there may be more than one right answer. And you might think, well, that's the only one that says multiply 13 by 5 and then divide it by 4. But if you look closely, and if you remember what we talked about with unit fractions, okay, this first one, multiply 13 by 5, that's the same first step. Multiplying it by that 1/4, think about if we multiplied a number, 12, by 1/4, what does that actually end up doing? Well, if you multiply across, you get 12 over 4. And multiplying, so we see multiplying by a fourth ends up really just being divided by 4. So that statement A could also be used because multiplying by a unit fraction is the same thing as dividing by that unit fraction. Multiply 13 by 4 divided by 5, that would not work. But that's a common mistake because people might try and do keep, change, flip, but I see a lot of people forget to flip that second fraction. So that's why that one's on there as kind of a trick answer. Multiply 13 by 1/5, so that'd be the same as doing 13 divided by 5 and multiplying it by 4. That's not going to give you anything close to what the original one was. All right, these are all keep, change, flip. All answers need to be reduced or simplified. Okay, so we keep our first fraction the same, 2/3. Change your operation sign to a multiplication sign. Flip your second fraction to its reciprocal. Okay, there's no cross simplifying that I can do on this one, so I'm just going to carry out my multiplication by multiplying these across. 10/3. Now that's an improper fraction, so I need to reduce that fraction. So whole groups of 3, can I take out a 10? 3, 6, 9, 12. So I'm just counting by 3s right now, counting on my hands. 12 is too much, so I can take 3 full groups of 3 away, which we said was 9. So if I take 9 away from 10, I'm left with 1/3. Same thing for B. Keep the first fraction the same, 7/2. Change your operation sign to times. Flip your second fraction to be 4/3. Now there is a little cross simplifying I can do here. With the 4 and the 2, I can divide both those by 2 before I multiply. And so then if I multiply across, 7 times 2 is 14, 1 times 3 is 3, and 14 divided by 3, I can take 3, 6, 9, 12, 4 whole groups away, and I'm left with 2/3. C, 5/9 divided by 10/11, 10/11. Keep the first fraction the same, change your operation sign, flip your second fraction. Some cross simplifying I can do on this one. I can divide both 5 and 10 by 5. So 5 divided by 5 is 1, 10 divided by 5 is 2. Multiply across, 11/18, and that's already simplified. If I didn't cross simplify and I just multiplied across, I would have ended up with, I'm just going to reset it up, 55/90, which I could divide both those numbers by 5 because one ends in a 5 and one ends in a 0. And so that would give me then 11/18 if I divided both of them by 5. So same answer. 4 1/3 divided by 3/2. So the one difference in this one is now we have a mixed number. So I'm going to convert 4 1/3 to a improper fraction, right? This times this plus this. Remember Miss Stamps' dance? This times this plus this. 3 times 4, 12, plus 1, 13/3. Now I'm just going to write out the division, even though I know I'm going to do keep, change, flip. I don't want to try and do too much in one step. Okay? Now that I have it as an improper fraction, I'm going to apply the keep, change, flip method. 13/3 times 2/3. No cross simplifying that we need to do, so it's just multiplying across. 13 times 2 is 26. 3 times 3 is 9. 26/9 is our improper fraction, and so I want to convert that to a mixed number. So 9, 18, so I can take 2 groups of 9 away. 2 groups of 9 is 18. 18 away from 26 leaves me with 8/9. All right, I'm going to grab my coffee. Give me 30 seconds. Trying to do this while you guys are at specials. A lot of talking. Oof. I need a little refresher. All right. Number 6, write a division equation for how many 3/4 are in 7/8. Use a question mark for any unknown numbers you do not need to solve. As we've done a lot, if I just put in easy numbers to help me get set up, that can help me immensely in making sure I have the right order in my division equation, okay? So pretend that the question said, how many 2's are in 10? How many 2's are in 10? If that's what it said, how many 2's are in 10, we could write 10 divided by 2 to find our answer. So when I compare that to this problem, how many 3/4 are in 7/8, because we did that example one, we can see that we're going to start the equation with that 7/8. And we're going to divide by our group size, 3/4. And we don't know what the answer to that is, so we're just going to put a question mark. 6b, use your division equation to write a multiplication equation for how many 3/4 are in 7/8. Use a question mark for any unknown numbers. So I'm just writing this division equation backwards. So I'm going to start at the end with the question mark. I'm going to multiply that by my second number, 3/4, and that should equal 7/8. We've done that a lot in the unit. Hopefully those were 2 quick review questions for you. Brianna's family is on a trip. So far, they have traveled 3/4 of the total distance. They have traveled 120 miles so far. How far is the full trip? So I give you a diagram here that has fourths, and we know that their trip, they've gone 3/4 of the way. So they're close to being there, okay? They're not there yet. And it tells us that they have traveled 120 miles in that 3/4 of the total distance. So that is going to be 120 miles. So my first step is to figure out what 1/4 of the trip is, because then I can plug that number into each box of my tape diagram, and my tape diagram, my full trip will be this, all 4 of these boxes combined. So to find out what 1/4 of the trip is, I can see I'm dividing that 120 miles by 3. Okay, 120 divided by 3. It's the same as 12 divided by 3, just with a 0 at the end. 3 goes into 12 4 times. 3 goes into 0 0 times. 40. So 1/4 of the trip is 40 miles. I'm going to put that 40 in each of these boxes. And the total trip then is just multiplying 40 by 4, or adding 40 plus 40 plus 40 plus 40. 40 times 4 is the same as 4 times 4, just with a 0 at the end. 4 times 4, 16. Add in that 0. So that's my final answer, 160 miles. All right, these two are probably the hardest word problems on the review. These are the ones that students struggle with the most. Maureen is painting some doors that are all the same size. She used 3 liters of paint to cover 1 4/5 doors. So almost 2 doors, 1 4/5 of a door. How many liters of paint are needed for 1 door? Okay, so they're not asking how many liters of paint are needed for 2 doors. That's what a lot of students probably are going to do right away. They're asking for 1 door. Okay, but the only information we have is how much paint she used for 1 4/5 of a door. So you can see my tape diagrams here are split. And that's because in the original problem we read, she almost painted 2 doors. So each of these full tape diagrams there we go. Each of these full tape diagrams represent 1 whole door. And we know that to cover 1 plus 4/5 of a door, okay, that's your 4/5 is right there. To cover 1 4/5 doors, she used 3 liters of paint, okay? So in order for me to figure out what 1 full door is, I want to figure out what 1/5 of a door is, kind of like the last one. If we can find what goes into one of the boxes, into 1/5, then I can figure out my other numbers. So if I count the total amount of fifths that my 3 liters is split into, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to erase those slash marks. Okay, so I'm splitting 3 liters by 9 different boxes. 3 divided by 9, that's your funky looking division problem. Write it as a fraction, 3/9, which reduces to 1/3. So that tells me that every box has the value of 1/3 of a liter of paint. So I'm going to put that in every box. Now, I didn't really have to put them in that second set because remember, we're just finding this 1 full door, okay? So then to get the total amount of paint in that 1 door, I'm going to be adding all these thirds up, okay? So 1/3 is 1/3, 2/3, 3/3, 4/3, 5/3. Which I want to turn to a mixed number, 1 2/3 liters of paint per door. That was a toughie. If you struggled with that one, you probably were not alone. Okay, this one's similar, but I think this one's probably a little easier. Carter used 1 1/3 gallons of paint to paint 2/5 of a wall. How many gallons will it take to paint the whole wall? Show your work below with the diagram or with the diagram to support your answer. 2/5 of the wall he has painted. So we see we have a tape diagram split into fifths. So using the information from the problem, 2/5 of the wall, use 1 1/3 liters of, gallons of paint. So I see I have to split my 1 1/3 into 2, okay? I'm going to want to turn my 1 1/3 into an improper fraction because that's going to make it easier to split. So if I write my mixed number, 1 1/3, and turn that to an improper fraction, 3 times 1 plus 1, 4/3. So now I can think of that as 4 1/3 pieces, which allows me to see that each, when split into two, each fifth would get 2/3. Right, so now we are finding this entire wall worth of paint. So I'm going to count by 2/3. I could also do 2/3 times 5 because I see 5 groups of 2/3 in my diagram. If I count by 2/3, you got 2/3, 4/3, 6/3, 8/3, 10/3. If I multiply 2/3 by 5, we get the same thing, 10/3. That's improper. I want to put it to a mixed number, 3, 6, 9. So 3 groups of 3 I can take out of 10. 1/3 remaining. So 3 1/3 gallons for the whole wall. I guess I could have circled that, but. Two more pages. Problems. A recipe for cookies calls for 3/4 of a cup of sugar per batch. Elena used 2 1/4 cup of sugar to make multiple batches of cookies. How many batches did she make? Show your work or use the tape diagram to help you. You may end up not using the whole diagram. Circle your final answer. Okay, so we see how I started the tape diagram for you, okay? Each of these boxes in the tape diagram will represent two things. It'll represent 3/4 of a cup of sugar, and it'll represent one batch, okay? So what I'm going to kind of do is I'm just going to keep adding 3/4 of a cup, and I'm going to keep a running total in my head of how much sugar we've used so far. Now, because I'm going to be counting by 3/4, it's going to be beneficial to turn 2 1/4 into an improper fraction. Okay, so 4 times 2, 8, plus 1, 9/4. I'm going to show you why that's going to be helpful. Because if I add another batch, which is another 3/4 cup of sugar, I am now, if I count 3/4 plus 3/4, that is 6/4, right? So if I add another 3/4, another batch, I was at 6/4, add another 3/4 onto 6/4, and that puts us at, look at that 9/4. So it only took 3 batches to get to 9/4, or 2 1/4. And so that is my answer, because the question is how many batches did she make? She made 3 batches of cookies. I think that was the last one for the review before the challenge. And so this one is optional. You only need to answer this question if you're going for a 4. In order to get a 4, you need to score high on the assessment plus get the challenge question correct. Attempting the challenge question and getting it wrong will not hurt your score in any way. It's worth it to try it. Tom and Jerry are looking at this tape diagram and they see different answers. They both agree that the problem is 4 divided by 3/5, but they disagree on what it means or like what the final answer is. Tom says that the diagram shows 4 divided by 3/5 equals 6 2/5. Jerry says that the diagram shows 4 divided by 3/5 equals 6 2/3. Mr. Lobbs loves a math fight because people are arguing about ideas and have to explain their thinking. Ah, bliss. Who is correct and why? So we can clearly see that there are 4 holes, and we can tell the holes because they put the kind of longer lines to separate our holes. And each hole is split into fifths. 1, 2, 3, 4, 5. Okay. Once they split it into fifths, they made their groups of 3/5. That's why you have those different markings. So we have 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 whole groups, which is what they both get in for their whole number. And then you have this remaining part. Okay? So this is where you have to interpret that remaining part as what part of a group is that. Okay? Our group size is 1, 2, 3 boxes. So this last part, even though it started out as fifths, when we say how many groups there are 6 full groups, and then this last part is only 2/3 of a group because a group is 3 parts. So Jerry is correct because that last portion represents 2/3 of a group, because the question 4 divided by 3/5 is asking how many groups of 3/5 are in 4. And so when you do 3/5, that makes your group size 3. We have to interpret that remainder as what part of a group. And because the group size is 3, it's 2/3 of a group. So Jerry is correct. Not you, Caden. Jerry from Tom and Jerry. All right. Let me know if you have questions.